So here we are going to understand uncompetitive inhibition. Now, first we have to recall that when we talk about inhibitors, we have three different types of inhibitors that we are interested in that are known as reversible enzyme inhibitors. We have the competitive inhibitors, the non-competitive inhibitors, and the uncompetitive inhibitors. So previously, we've already discussed that competitive inhibitors, they will bind to the active site of the enzyme, so they are competing with the substrate. For non-competitive inhibitors, they are binding to the allosteric site. Now, the key distinction between uncompetitive inhibitors and non-competitive inhibitors is that non-competitive inhibitors can either bind the enzyme by itself, or the non-competitive inhibitor can bind the enzyme substrate complex. So it can bind either or. Whereas in uncompetitive inhibition, this enzyme can only, this inhibitor can only bind when the substrate is bound to the enzyme. So once the substrate comes in, binds to the enzyme at that allosteric site, then that inhibitor can come in and bind to the enzyme. So essentially, the hypothesis and the theory behind that is that when the substrate binds to the enzyme, the overall enzyme substrate complex goes through this conformational change, which exposes a site where that inhibitor can bind. But what's interesting is that the inhibitor itself can also bind the substrate in that enzyme substrate complex as well in some rare occasions. So to review, uncompetitive inhibitors, they're a class of inhibitors that can only bind to the enzyme after the substrate has bound to the enzyme. And remember that uncompetitive inhibitors and non-competitive inhibitors, they bind to the allosteric site, which is just any other specific location on the enzyme that is not the active site. And competitive inhibitors will bind to the active site. Now, we're going to take a look at two specific things over here, and this will make more sense once we discuss the Lineweaver-Burke plot and Michaelis-Menten plot in the following videos. But for uncompetitive inhibitors, Vmax is decreasing. We can think about this in the sense that if we have an enzyme substrate complex and the inhibitor binds to the enzyme substrate complex, we have less enzymes functioning to their maximum ability to have a greater Vmax. So if we're reducing the amount of functional enzymes, Vmax is going to decrease. And Vmax is that maximum initial rate at which we can convert that substrate into product. Now, interestingly, Km is decreasing. Now, Km can mean different things. So when we talk about Km, first of all, it is the substrate concentration at half our Vmax. So at 1/2 Vmax, that will give us our Km value. And also when we talk about Km can refer to as affinity. So a low Km will be higher affinity, and a higher Km will be lower affinity. And in uncompetitive inhibition, Km is decreasing, so a low Km means high affinity. How can we make sense of that? So this process of substrate combining with enzyme to form that substrate enzyme complex, it's in this equilibrium. So we know that when we talk about equilibriums and we consider Le Chatelier's principle, if we reduce one thing, that equilibrium is going to shift to make up for whatever is being lost or whatever is being affected. So if I have this substrate enzyme complex, the substrate and the enzyme have joined together, and then I have that uncompetitive inhibitor come in and bind the enzyme, then we have rendered this complex inactive, and we're reducing the amount of available enzyme that can convert that substrate into product. So as a result, we are reducing the concentration of substrate enzyme complex, and this equilibrium will shift to the right to circumvent that change. So it appears that the affinity is increasing for the enzyme because we're moving this way. So it seems like, okay, the enzyme must have a greater affinity for substrate. That's why we're moving this way. But in reality, we're moving this way. The equilibrium is shifting this way because we are reducing the concentration of substrate enzyme complex that is effectively converting that substrate into product. So lower Km is equal to higher affinity, but in this sense, it's not really about higher affinity. It's just the fact that we're circumventing that change that's happening. And then lastly, this is also a reversible enzyme. So the three enzymes inhibitors that we had, the three enzyme inhibitors that we have gone over, non-competitive, competitive, and uncompetitive, they are all reversible enzyme inhibitors, and the non-competitive and uncompetitive inhibitors will bind to the allosteric site. And essentially, this is a quick depiction of what happens. You have that enzyme, you have that substrate, you get the enzyme substrate complex. This is where an uncompetitive inhibitor will bind, whereas a non-competitive inhibitor, it can either bind enzyme by itself or it can bind this complex. Then we will have this brief interaction between enzyme and product, and then we'll get the separation of enzyme and product. And so that is essentially uncompetitive inhibition. We just have to understand Vmax is decreasing, Km is also decreasing due to that shift in equilibrium, and this is unique to uncompetitive inhibition.